This lesson is on special right triangles, and we are specifically focusing on right triangles that have angle measures of 30 degrees, 60 degrees, and 90 degrees, which we call 30, 60, 90 triangles. This is very similar to the 45, 45, 90 triangles that we saw, but the relationships are just slightly different, even though the ideas are the same. So, if we have a right triangle, we have a 30-degree measure and a 60-degree measure. Right? So it is not an isosceles triangle like we saw with the 45, 45, 90, but we do have 30 plus 60, which is 90 plus 90, giving us our sum of 180. We can use the angle measures to help us find the sides of the triangle. Again, this can be done using the Pythagorean theorem, but this is supposed to be a shortcut. So if you notice that it's a 30, 60, 90 triangle, you can use the relationship of the sides to help you find the other sides much quicker than if you would use the Pythagorean theorem. The first relationship is the side that is across from the 30-degree angle. If we know this side, we can find the other sides very easily. 30 is represented by x, just x by itself. Once we know x, we can then find the side across from 60. The side across from the 60-degree angle is represented by x, the square root of 3. And if we know x, we can also find the hypotenuse, or the side that is across from the 90-degree angle, which is represented by 2 times x. So here's the diagram that shows the relationship to the angles and the sides, but we can also write this out as an organized formula. So again, 30 has a relationship with the variable x. The relationship of the side across from the 60-degree angle is x to the square root of 3. And the relationship of the side across from the 90-degree angle is represented by 2x. Again, make sure you have these down in your notes, both the diagram and the formulas, so that you can use this to work through the problems and examples that we'll do in class. The first example is to find W and Z using the diagram given. So again, using the triangle sum theorem, we can determine what this missing side is, but anytime we see a right angle and a 30-degree measure, we should quickly recognize that the missing side, or the missing angle, is going to be 60 degrees. So now we can use this information and use our formulas to help us find W and Z. Again, we know that across from 30 will be represented by x, across from 60 will be represented by x to the square root of 3, and across from 90 will be represented by 2x. Using this, we can find what do we know. Well, we have this information 9, which happens to be across from our 30-degree angle. And again, across from the 30-degree angle, we know that's equal to x. So we know our x is 9. Once we know x, we can then easily find the measures of the other sides, because both the 60 and 90-degree representations involve the variable x. So all we have to do is substitute our 9 in for both of those values, and we can easily find the sides across from 60 and the sides across from 90. And in this case, across from 60 is being represented by the letter Z, and across from 90 is being represented by the letter W. So once we find or substitute our 9 in for x in both of these, we've found Z and W. So for the 60-degree measure, again, 60 corresponds to x to the square root of 3. We know that 9 is x, so our 60-degree measure is 9 to the square root of 3, and therefore we found our Z, which in this picture is 9 the square root of 3. Right. Now we can again substitute 9 in for x to help us find our 90-degree measure, or our W. 90 is represented by 2 times x. We know that x is 9 because it was across from the 30 degrees. So we have 2 times 9, which is our x, or 18. So we have also found our w, or the measure across from the 90-degree angle. The next example also has a 60-degree angle, but we need to find 2 of the missing sides. So again, we can set this up once we have our right angle and a 60-degree angle. Using the triangle sum theorem, you should be able to find out that this side is 30, but hopefully you can quickly recognize that if we have a 90 and a 60, this third side has to be 30 without using our triangle sum theorem that the angles add up to 180. Again, we can set up our formula. Across from our 30-degree angle is represented by x. Across from our 60-degree angle is represented by x to the square root of 3. And across from the 90-degree angle is represented by 2x. In order to find our unknowns, which in this case is c, which is across from the 30, and d, which is across from the 90, we need to use the information that we do have, which is the information that is across from the 60. So we know that 60, which is represented by x to the square root of 3, is equal to 3 to the square root of 3. Now, we're going to have to do a little work before we can find our x, which is going to help us find our 2x. So we use this equation to help us solve for x so that we can find c and d. We could say x to the square root of 3 is equal to 3 to the square root of 3. Since we're looking to get x by itself, we want to get rid of our square root of 3. We can do that by dividing the square root of 3 on both sides. And it works out nicely that the square root of 3 simplifies. The square root of 3 simplifies, and we're left with just x is equal to 3. So if x equals to 3, we've found the measure across from the 30, and we can substitute our x into our measure for the 90, which we know is going to be 2 times 3, or 6. So we can substitute these values in. Our d is going to be across from 90, which we found to be 6. So d is equal to 6. And our c is the measure that's across from the 30, which is just represented by x. So we know that c is equal to 3. Make sure you bring these notes to class so that we can take questions on the examples and use our formulas to go over more examples.